Hello and welcome back. My name is Corey and you're my rubber ducks for the evening, and this is the series of episodes where we are creating a programming language from scratch using modernish C++, a terminal window. Vim is our text editor, using basic tools such as Flex, Bison, ICU, and Google Test. Yes. And we've been working on this for a while. We are in the middle of reworking our opcodes to be more efficient, and this is indeed giving us speed enhancements. And what we're doing is our machine is a stack-based machine, and we wrote all of our codes so that they would read from the top of the stack. So if we needed to add something, of course, maybe a variable a is stored somewhere in the stack, we would copy that to the top of the stack and then copy whatever or create whatever we're adding it to, and then call an add opcode, and it would pop those two operands off, add them together, push the result. And that was fine, but we are trying to do more work than that. Well, what we're doing now is we're saying, well, if there's an A there, I already know it's index. Why don't I just reference the index directly instead of pushing it onto the stack? And we've been doing that so far. We've saved, I know it's over 10% of efficiency. We're going to continue on this now. And let's see, before we get started, what do we always do? We do our make clean to make sure that we're starting with a clean compile, make test, and so that'll get started on the right hand side. On the left hand side, we'll say get log, show that the last commit was the end of episode 93. That was the previous episode. And get status, we'll see that there are no changes. There's just one file that's a call ground file from before we started doing any changes. And I guess I could get rid of it, right? We could always recheck out that earlier episode and go back to this. But anyway, I'm leaving it there for now. But no changes. All right, so what do we want to work on today? Well, I went ahead and pulled up the opcode. And by the way, yes, this is live coding, 100% live coding. You can think of this as a performance piece. That is, I wanted to have a non-trivial program that you see coded from scratch. The very first episodes are a blank file window. There is nothing there, not even a make file to start off with. And we create everything from scratch. So yeah, you see me make mistakes. You see me have to refactor stuff like this. And I was looking through here, and what I think I want to work on is we've got all of these, the SI versions. S means the stack, pull from the stack. I means use an index into the stack. And we could do assign index because we have to pop an index location, pop a collection. Well, if that's A sub B is equal to, a value, that's three different things that we could potentially save on. But if there's three options and there's two values for each, that means 8 different commands. So I think I'm going to hold off on this one at the moment. But where is this? The one I was thinking about. Yes, period. So the period operator, and I think the index operator is going to be pretty big for us, where we say a square bracket something. Yeah, so we'll look at period and index today. And we've been repeating a lot of code, so I think I kind of want to abstract that out even more into a macro, and we will worry about that today. Our time right now for our test has been hovering between 4 and 5 milliseconds, depending on the time that it's running, and that's perfectly fine. We're going to open our include for opcode, our source for opcode, and what else? We're going to need our include macros, because like I said, we're going to do a macro. And what after this? We're going to need our source for our AST node. What did I say? We're going to do period our source for our AST node. Did I say index? Yeah, index. And I need to refer to one. Let's do our source AST node. How about binary? Yeah, that should work. Source AST node binary. Yeah, all right. Got all those open. And first, let's just look for period. We'll do period first. So period, we see that we could have an, so there's, oh, this is a 4-1. So we're going to, there, okay. And 2, 3, 4. And we're going to have an SS, SI, IS, and II. All right. And we may do this. We may just do index at the exact same time. Why not? SS, SI, IS, II. Okay. And now it's complaining, yeah, hey, I don't know what to do about this. That's fine. Okay. So opcode.cpp. Look for the word period. We found it. There we go. And this is SS, SI, IS, II, SS, SI, IS, II. Okay. Keep going. This is, what are we in? Oh, macros. This is our new file. We're actually going to write macros. We haven't been doing that. Okay. We'll get there. What should this look like? So I'm going to go to number 6. So we've got this binary op thing. And logical op. But this whole thing about the identifier, trying to figure out the index values, that is repeated, right? Yeah, and how it's okay, how far is this? From 16 down to 72. Oh, that'd be 56. I think that'll grab it. And let's go to 3 just for the moment. Oops, 4 just for the moment. And say if I have all right. What I'm looking at is you got to do the left-hand side. So this is weird. Okay. What I'm wanting to do, so from here down to here, we'll load something into some identifier. And I want to find index for something. Did I do this wrong? But this is opcode. Okay, normally I don't do this, but I'm going to. There. And what do we need? We need the... This needs to be... we need to pass in the expression. And the index. All right, so what we're going to be doing is this. There, back. There. Same here. and then index. So that will set an index if it exists. All right. Should probably put that there. The only reason I'm doing this is so that identifier can be automatically declared, and I don't have to do it here. So now I should be able to say find index for and call it LHS index. All right. And I should be able to repeat it for the right-hand side. All right, now this, by the way, would go in the binary op, even though I'm doing it here. What I'm wondering is the period is a binary op, is a binary operation. That is, there's two sides of it. So it starts on 16 and goes down to 64. Well, there, this is the easy way. Go to the macros. It doesn't have to be inside the Tang thing. So Now I think I can get rid of this. Oh wait, there we go. There we go. Okay, so that should be fine. What is it not liking here? What I'm not sure about is why does it not like me just referencing add? Because I'm saying using namespace Tang. Should not matter about that, but I have a feeling it's gonna complain, so Or is that the big problem? That binary op wasn't declared. So maybe because I didn't save it? Those are there. That makes sense. Yeah, I'm pound including macros, pound including opcode. Oh. Okay. So if I delete these, okay. Identifier, AST node binary, Okay, now if this compiles fine, I'm going to go ahead and commit those changes to macros and the binary. Index is not a member of opcode. Oh yeah, because it should be index SS. But we're not there. We're now on so I think it's going to be. Oh, this is the problem. I need to specify. That's okay. We can deal with this. Problem is that's a shared pointer, and this is going to be there. Now I can pass that in. There. All right. So binary op really needs to take the fact that there's left-hand side and right-hand side. Yes. And then what are the 4 options? We're about to fix this now. Which one is macros? So we need an LHS, RHS. There. So instead of well, really from here to here plus 25, we're going to substitute this arrow LHS to be LHS. Okay, we'll do the same thing. Whoops. But I got to go back up to where I was. Do the same thing, except it'll be RHS becomes RHS. Okay. That works. All of this should work. And now it's going to complain on the binary because this now all needs that right there. Oh, logical up? Maybe no. Okay. Binary is now compiling. And the whole point of all of this is if we look at period, it becomes this really, really succinct thing. Okay, so now index is also wanting some attention, so we're going to pound include macros, and what will it look like? Get collection, it's compile, collection, and index, and index. Period is going to become index on all of those. And that goes down to, oh, that should be macros.hpp. Now we're breaking stuff. Okay. What did we break? Oh, is it just because I need to pound include AST node identifier? Yep, that fixed it. Well, fix that one. Probably have the same problem. Yep. Identifier and string. Oh, just identifier. Whoops. This, we don't want to call compile. We just want to pass it in. There we go. So it's not liking, go to line 21. Should just hit ZZ and that will, so ZT will put it at the top, ZB will put it, well, I thought it would. ZZ will center it. So ZT top, ZZ will center. Anyway, so the problem is it knows that expression is a shared pointer to an AST node string. Normally it's a shared pointer to an AST node. But in this particular case, so what I need to do, this is in period, so is instead of doing auto, say this is a shared pointer to an AST node. And then it will behave. Oh, yeah, we got to do the other stuff. Program analyze. But that's good. We've gotten past all of the compile points. So edit, program analyze. We've got several things to do, but that's fine. Period. So we're going to go here, here, here. There we go. Now we've got all the periods, all the indices, SS, SI, IS, II, SS, SI, IS, II. All right, and then we need the dump program check and PC plus equals 2. On SI, IS, and II, except that will be slightly larger. remove these unnecessary increments for PC. And then this one's correct, and this needs to be incremented by 1. There we go. And that one's correct, and this one needs to be 1 larger. Okay, let's edit the next one, source program dump bytecode. Well, this is going to be dump binary. And that one's going to be dump binary. And now it's going to be dump binary underscore I underscore I. There. Okay, so we've got 4 periods. SS, SI, IS, II, SS, SI, IS, II, and then last but not least, I did it wrong. That's all right. Underscore II, underscore I, underscore I, and this should be that. Need one more I there. Okay, we've got all of our dump stuff correct. And the last is in our execute. Okay. Didn't mean that one. Period. There we go. All right. So, and I've got these binary op things. Okay, so I just stole these, and I think I'm going to dot comma dot plus 19. Okay, and I want to substitute what? NEQ for period. Okay, so all of those are like that. I'm going to do it again, and this time I'm going to say not equal. I think it is dot dunder period. I think that's it. I'm about to find out by scrolling down. There we go. Uh-oh. Well. That's all right. Evidently I don't need these. Okay, so see if this all makes sense. If so, we'll just continue copying. So we do the binary op, and that gives us the LHS and RHS. Yep. And now we call it LHS arrow dunder period with RHS and Tang. That's fine. If it's a computed expression native library function, we cast it as such and say get function in the context. We may have to do this multiple times. That is why it is a while statement. If it's a native bound function, then we set the target appropriately, then we push it. Okay, so this needs to go in all 4 of these. Yep. Wait. And then I can get rid of the actual period. All right. Now, I can kind of do the same thing with the index. I want to go up and grab those same 4 not equals again. Put those right there. So not equal now is going to become index. Left-hand side, RHS, right? Because that's what it's going to give us. Left-hand side, right-hand side. All right. We will see if this compiles. I mean, it's compiling. Okay. Well. This is always scary. It's like, what did we do? I don't know. I'm pretty sure these are about to fail, but we'll run it again. And for the moment, let's open test. All right, and we'll find the first one that fails, or maybe the last one. Maybe I'll just be lazy and only do the last one. as we wait for the compile. And of course, I'm only using one core right now to compile. Normally, you wouldn't do that. And of course, it's compiling on the highest optimization. I'm okay with that. Just makes it take a little longer. But since we kind of care about optimization, that's why we're doing it. Okay, 2406, that's the last one. Let's go to there. 2406. What on earth? Let's, print this out. We didn't touch the a is equal to 1. We didn't touch the print. Null val, integer 1. Oh, that's for this one right here. So null val is reserving the space a. Integer 1, poke that into a. Subtract is. Subtract 0 from... Well, what's on the top of the stack? 1. Shouldn't it be the other way around? Shouldn't it be subtract si? You know what? It should be. Let's go back to the binary, B6, and all of these left-hand side, right-hand side. Wait, isn't that right? Left-hand side, right-hand side. Check macros. Left-hand side, right-hand side. So this right here, these two lines, if I look at this again, 0, null val, that's reserving the spot for a. Integer 1, poke that into a. That's fine. Wait, why aren't we doing the 5? Where's 5? We broke something, definitely. Should have been an integer 5. And wouldn't that be SI, not IS? So let's go back to our macros. So our binary op is saying left-hand side, right-hand side. We find the index for LHS using LHS index. Find the index for right-hand side with RHS index. And now we just use these. So in this case, LHS index exists, but if RHS doesn't, then it's that. Okay, so what's happening with opcode find index? So we are passing in the left-hand side, the right-hand side, SS, SI, IS, II. Under what case would we get IS? Subtract IS is the next to last. Okay. Here, it is also the next to last, IS, and that's in this case, where the left-hand side index, it found something. The right-hand side, it did not. So, opcode find index is messed up. Where we take the expression and an all capital index. LHS index, look at that. That should have failed in a lot of areas. That happens. Thank goodness for unit tests, right? Otherwise, I don't know if I would have caught it right away. Okay, now look, we have we poke it, pop it, integer 5, subtract SI of 0. That's fine. The S is the 5, the I is A, and then we print it. Yeah. Um, let's remove that dump bytecode. But no. There. Well, I want to... I'm looking for an example that I can explore the bytecode of. That's in the compiling of a template. Context, I forgot all the stuff that we did. But you know what? I want to see this one. Because this... Yeah, okay, so we've got... We don't have any variables to reserve a spot for, but we've got this A, the word custom function, B, and C. And now, a period II of 0 and 1, A.custom function. Yeah. And then we call that function with 0 arguments. And then we call its result with 0 arguments. And then we print it. And then pop the result. That is very, very succinct. Same thing here. Okay, that's good. Let's... I want to see something with a subscript. An index. Well, these are... kind of. That's going to make the a.append, and all that's going to be significantly... hello world.length. This one. This looks good. So these val sub 0, the sub 0, because it's we're not optimizing for that, so it will... There we go. Function change. Function strings, foo, that's fine. That has been put onto the stack. We copy it to 0, which will be val. Oh, val sub 1. No, that makes sense. Okay. The code block, sorry. Peak 1, that's going to be foo. Peak, wait. Integer, assign. Oh, these are assign index. Where's the print? Oh, print s, index is. Okay, that's fine. The I is going to be val, and integer 0 is that one right there. So I like seeing these mixtures of IS's and I's and all that other stuff. That means we're getting a lot better performance out of our code. Any others? String index. Oh, here's the regular indexes. indices, whatever. Yeah, let's leave well enough alone. All right. All sorts of stuff. We need to add things in the makefile for these macro dependencies. Period index. We removed it from, what is this? AST node binary. AST node identifiers, simplified that stuff a lot. Okay. So AST node binary macros. We need to add macros. And is that what it's called? Tang base. Program. Context. Oh, but there is a det macros. That's the point. Yes. All right, what else did we put it in? We put it in, so we did binary. We're going to need it in, well, I'm assuming nodecast and other stuff. So node assign, will we use it in assign? Yes, we will. Will we use it in, we already added it to binary. Okay. Node cast, yes, we'll use it there. The node for, it's not the ranged for. The regular for could definitely have it. So, okay. The function call, yeah, that'll need it. Oh, and that'll need the string as well. Oh, that means I probably haven't optimized the function call with the string passing. I could be, maybe I did, but oh well. The if else will definitely need it. Index will need it. It did use it, okay. Period, yep. Print, maybe. Yes, I think it will. I just haven't added it. Ranged for, yeah. And in fact, we need string on that as well. Return. Yes. Slice. Yep. Unary. Haven't converted it yet, but it's gonna be there. The while, yep. All right. So while that's doing it, we're going to say git add makefile, include macros and our source for AST node binary, and the commit will be into a macro. 79 insertions, 86 deletions. That is big. I mean, we reduced the amount of code. All right. And that's even adding lines to the makefile. Now, include and source. Make sure we're not doing it. Yep. Okay. And what did this do? Add SI. Okay, get log. What wording do I use? Optimizations. Add SI opcodes. Okay, we'll do that. Opcodes for period and index. Anything else? Sorry, I'm thinking. Nope, that's fine. All right. Now, there's one or two last things I want to do. Just they don't fit in anywhere in the terms of a grand video. So this will only add a few minutes, but I want to get it done anyway. First of all, if I run this a couple times, oh, whoops. Six milliseconds. We got a bad one there. It's staying steady at 4. All right. In fact, time build apps test. I don't think we're going to be able to see anything. Yeah, it's the 4 milliseconds plus whatever it's taking. Okay, that's fine. All right. The other thing I wanted to do is time build apps Tang -s fib. Right, we've done this several times. We're expecting them to all be, you know, kind of below. There we go. And I'm just putting it here in a new file. Yes, I still have the old ones, but I'm not worried about that. What I'm wanting to do is now vim source thinking. Oh, is it not not in source? Is this a header only thing? Include Singleton Object Pool. I am curious all the places that it has the word lock. Not the word block, but lock. So they're all commented out. Completely new compile. I want to see what our timing is. In other words, I want to know how much that mutex lock is hurting us. Maybe nothing. Maybe significant. Well, you tell me, is it hurting us? A tenth of a second when we're only at 0.5 and 0.6, that is 15%? Yes, it's hurting us. Is there a way we can get rid of it? Not the mutex, but maybe the whole Singleton Object Pool thing is... actually, I think that's faster, but I would have to guarantee that... The reason it's faster is because it only has to do a malloc once. Maybe doing a malloc all those times is just faster at this point than the overhead of trying to use the pool. Think about it. That is, I will think about it. All right. Okay, so we need to undo all of that. Everything's having to recompile. That's fine. All right. I should probably just change that so that it's make docs will make the PDF. I don't know. We added some macros that will probably get picked up, and yeah. Why am I saying get log? So I know what episode we're on. So we're on episode 94. Okay. Not show, get status. There we go. git commit dash m update docs for episode. I just looked at it. I don't care. Oh, episode 94. Push that up. There we go. The last thing is checking out how many lines of code. 12,600. Not bad. And we see that we still have some work that we can do. If we can figure out another 10% would be, just fixing that one. I know that we're getting performance gains. I think it's just too small to really measure with the kind of small programs that we're running. But I know that it's improving performance. It's sub milliseconds. We need a larger program that implements those. The problem is the Fibonacci program doesn't implement any of the instructions that we've been doing. So anyway, that's fine. What the Fibonacci program emphasizes is how much work it takes just to perform, to execute the commands. And that inefficiency with the Singleton Object Pool, we're going to have to figure out a good solution for that. All right, so that brings us to a good spot. We can quit for the evening knowing that we've made some good progress. Which opcodes do we have left? I think I've even got that handy here. If we look at the opcodes, I can refresh this and our new opcodes will show up, period, and index. We could do slice, but that's going to be a skip, end, pop, and collection. Oh my goodness, that would be 16 different things. I'll have to think about that. What's a good way of doing that? But things that we can do is, where's the assignment? Assign, not that one, but assign index. We've got to pop an index and a collection. Again, those could both be an S or an I. And at that point, we just need to make sure that we've we can use our macros, which will give us the string enhancement automatically. And we need to add that to our unary and maybe a few others, but our casts, we haven't done that. Our print, I don't think we're using it there. So yeah, we still definitely have some things. And the return, we yeah, that could also be no, the return should always, it's whatever's on the yeah, the return, it's always got to be on the top of the stack. So I think return is fine. But so we're down to the point we just have to get everything applied to all the things that we've done. In other words, make sure we're on the same page with all of our things. Get iterator, we could do it with iterator. Get iterator next. Let's look at that. When we where does the iterator get stored? Does it go into a spot on the stack? We'll think about that. Okay, but all that to say, we're in good shape. Might only have one or two more of these conversions, and then we can deal with some other issues. So, all right, once again, thank you for joining me, and hope you have a great day, and hope it's been entertaining or something, somewhere in between. Bye.